you guys for being here. Today I'm going to talk about energy efficiency for your data science ecosystem. But why is this topic important at all? If you look at the chart on the right side, you see that in every minute in 2019 there is a lot happening. So, for example, there is 2.1 million snaps created. We cannot even catch up looking at this content as a person, right? Or, for example, on YouTube, there is 4.5 million videos viewed. If you have kids, you probably know this video, Baby Shark. And this is a very short video. It's just a song for kids. It's like around 2 minutes. And it's been viewed 4 billion times. Yeah, we also heard it this morning. So 4 billion views of this very short video, it's a lot of energy consumption. It can even power up, like if I want to translate this for something more tangible, it's enough to power 155 households for a year. And when I say households, I mean like all the appliances, everything included. It's a lot of energy consumption. If you want to have all these services up and running 24/7, we need to consume a lot of power. Yeah. And if you look at the forecast for energy for the IT sector, you can see that it's even increasing more. Like the demand is more, and we're also doing more computation. We are automating more services. So we're even like going to the direction of like even consuming more. And if you take, for example, 2019 as an example, it's around 2.5 terawatt hours a year. And to make it more translatable to what we can compare, actually, it's more than energy consumption of India and Russia in a year. So if IT sector was a country, it would be like in the list of top four countries that consume energy. This is a serious issue. And also, I think, as the data science community, we can have big impact. In the organizations we work, we can actually make insightful decisions about this. Okay, so some terminology here. But what do we talk about when we talk about efficiency? Efficiency is output divided by input. You want to maximize the output by a given input, right? And you can apply this formula to many domains, many scopes. Like, for example, take this picture as an example. You have 1,500 watts of sunlight, and then you get, for example, 450 watts of power. So efficiency is around 30%. Okay, we can apply this for energy efficiency and look at it from the task perspective. So given a number of tasks, you consume an amount of energy. So what you want to maximize is to, like, for example, maximize the number of tasks or minimize the amount of energy, right? And we also have power consumption, which relates to the rate of the energy consumption over time. To measure power consumption and energy consumption, there is many kinds of formula in the literature, but most of them actually come to this formula that they divide per component. So you take each component in the system, and then you measure the static power and then the dynamic power, and then you multiply that with the weight, and then you have the power of total. Why do we actually separate the static and dynamic is because usually when you turn on electric devices, you already start consuming because you are in the standby mode, and then as soon as you try to have utilization rates, then you have some dynamic power added up to the static power. And then the power of total power multiplied by the duration of the execution, you have the total energy consumption. So how can we actually measure energy efficiency in data science? To do that, we need to answer a number of questions from different perspectives. So for example, what are we measuring? What kind of tasks are we talking about? Is it about data cleaning tasks? Are we talking about, for example, monitoring tasks, about, for example, model training? What are we focusing on? This is very important because then you're also talking about the components that you want to measure, right? And what kind of resources are involved in this setup? Are they like cloud-based resources, or are they on-premise, or do we want to talk about, for example, computation-intensive tasks, and then therefore computational resources are involved, or about network? What is the focus? And also from which user's perspective? Are we talking about from, for example, AWS providers' perspective or from Randstad? Then this completely changes the story, how we can approach the problem, actually. But all this story that I said, it's at the end comes to having systems being self-adaptive. So when we have our systems self-adaptive, they can adapt to new changes at runtime and make new actions based on the energy consumption and the changes in the patterns and stuff, right? So to make your system self-adaptive, you need to realize MAPE functionalities. It's very easy, 4 steps. First, you start by monitoring the resources. You analyze all the new information, and then you detect some changes. You detect some abnormalities, and based on that, you plan the next execution step that you should have, and then you execute. Again, you monitor to see what was the impact of all the changes you made to the system. But then, how can we employ that MAPE functionalities in the data science life cycle? This is the life cycle we have at Randstad. Probably you have a similar setup in your organization. So first you start, for example, with business understanding. What is the problem we're going to solve from the data science perspective? And then you try to understand the data, what kind of data sources I can use. And then you start doing some POC experimentation. Okay, what kind of model can I use for this? Which hyperparameter tuning is going to work best for this? How can I scale this solution up? And this sort of questions for the POC experimentation. And then you start, okay, if it's a decision to go towards solving that problem, then you go to the phase of planning the project, and then you implement it, and then you maintain it, right? The tips that I'm covering today is going to help you with these 3 steps. So for the POC and the implementation and maintaining the solution. And usually, like, you want to actually think more for the last 2 phases, because these are the steps that are going to last in your organization. And if you think more and then you are more insightful about the decisions you make in the last 2 phases, you're going to benefit more in the long run. Okay, so tip number 1, I already mentioned it a couple of times, is that you need to monitor your resources. Who in this crowd actually monitors resources for energy efficiency purposes? Oh, you do. Okay, that's nice. I didn't expect actually to see any hands. That's good news for me. But usually companies have thresholds for like higher utilization of resources. Like we usually get alarms, oh, okay, 80% of CPU is utilized, RAM is going to be used that way, and we are alarmed by that. But usually we're not actually alarmed with low utilization rates, and we don't care about that, right? So we're like, okay, in the POC experimentation phase, we're like, okay, give me the biggest instance you can give me that I try this model and I see that it works. But it's really important to get insights from the patterns, and it also gives a lot of insights about the domain. Like, for example, you might have a scenario that your systems are not used during the weekends or after working hours, so you could actually tune based on that and save a lot of energy with that. So one approach would be that you could actually rely on the cloud provider itself. These days, they have a lot of data about how we use our resources, and they actually provide insightful reports. So, for example, this is from AWS Cost Management, and you see that they can offer like utilization rates on monthly basis, costs, and also usage hours. This simple graph shows, like, for example, on different months, what was the cost on different services, and in how many hours they were actually used. So this we can actually use to see, okay, how much we're using the services and with which utilization rate, and we can benefit from this. Even like from AWS, for example, I think other cloud providers have similar services. You can even get purchase recommendations. It's really interesting. Like they say, like, okay, so you have used these 3 instances last month, and you cost this amount. So maybe you want to replace those 3 with this another instance, and you save up this amount. So these are interesting insights that you can get from the providers and actually embed in your own systems. They also provide APIs, and you can actually use it from your own systems. Another approach would be that you take control yourself. So you say, okay, I want to have this auto-scaling, use auto-scaling groups, as we do in Randstad. And so with auto-scaling, you define a range. You say, okay, I need this minimum number of instances, maximum number of instances, and based on the utilization rate, it's going to fluctuate based on that, and then the number of instances goes up and down, right? Or you can go even like more complex with that, and then you can define 2 different schemes, like a scale-up scheme and a scale-down scheme, and then you plan, use cron jobs to actually plan it accordingly. Like for example, we are using auto-scaling groups for serving one of our APIs, and we want to make sure that we have 2 instances running at working hours, and in the other hours, we just want to have 1 instance there. And based on the patterns, we know that, okay, that's going to be enough. Therefore, as you can see here, like we change from 1 node to 2 nodes over time, like 2 times a day, because, no, it's like, yeah, today, no, 1 time a day. And then we also define the cron job, look at what time it should start, and then if you look at the utilization rate, it's looking very stable. You also can use Python libraries to include the monitoring information to your program. Like for example, this PSUtil, you can get the CPU percentage at a given time, and also like all information about your like memory, like okay, what is the available memory, what's the percentage, and stuff like that. Okay, tip number 2, choose your ML models wisely. So you can actually adopt to use resource-efficient models. You can be insightful about that as well. And you can, so there is a lot of models, like there is a lot of libraries that you can use it fresh off the shelf, but they are not customized to your specific problem, right? So you can, if you try to investigate more, okay, how can I actually use the hyperparameters? Based on the previous talks, even in this conference, there were suggestions that you should actually understand each hyperparameter better, and then you can actually tune better based on your problem. And it's going to save also in terms of resources that you're using. Like, for example, there are also some models that are provided for the purpose of being more energy efficient and for also resource efficient, which at the end translates to more energy efficiency. Like, for example, these algorithms that neural nets that are introduced by Google, EfficientNet. So they use less number of flops for higher accuracy. And you could, for example, when choosing different algorithms, you could, like, for example, consider that also as well. So the whole idea is that you bring energy consumption into equations. Like there is this research comparing NLP algorithms, Elmo and BERT, and then if you look at the results, you see that, okay, BERT is much more energy consuming, and also like in different set of hardware, and it's also consuming a lot of money in terms of like cloud computing costs. I'm not saying that don't use BERT. That's not the message. That's the message I'm giving is that just be insightful about this. It might be the case that only BERT can solve your problem, but you need to be insightful about that and make that decision. To be insightful, so one way would be to also use energy-related metrics. So, for example, when you're using MLflow and you want to, like, for example, log different kind of metrics about the model itself, you could also take into account the training time, or, like, for example, what kind of resources we are using here, or, for example, what is the CPU percentage, which I just showed, like with PSUtil, you could also take it at a given time. So this will also change the way you look at the problem. It's not only about the model, but the whole picture. Like, okay, because at the time you're productionizing this model, you're going to use resources over and over again. So it's really good that you know, okay, this is going to be the impact of my algorithm in the long run. Another important factor about machine learning algorithms is that we need to retrain them. But we need to also answer this question, like how often is too often? And like, what is my strategy to actually make the retraining schedule? Do I do it based on just some fixed schedule? I say, okay, once a week I want to retrain this model. Or I have another mechanism, like for example, I base my decisions based on some performance degradation. These are some kind of discussions that you should ask based on the data you have. Like, for example, if my data set is not changing at all, like in terms of distribution, maybe also there is no need to do it too often, to retrain every week. So we should be more careful about like how often we want to retrain. Because retraining is not only about the model, but you also do a lot of pre-processing to make the data ready for the model, right? So all these steps are energy consuming, if not for the good purpose. So, last tip is about optimization of your code. So it's really important that you use efficient data structures, efficient libraries, and also coding styles. You also should go for computationally efficient algorithms. It's sometimes the code might look ugly, but at the end, you will have a better serving code for the environment. I'm not saying that the code should not be able, like, don't care about the code, that it's not communicative to other people and it's not readable at all. No, that's not the message. What I'm saying is that make the trade-off. All the time think about another aspect of the code that you can take into account. Like, for example, okay, I want to copy this data frame. Yes, I need to do that because I don't want to, I want to make a functional code. But then how many times do I copy that? This is the question, the trade-off you can make, right? And it's also interesting to know that faster is not always better. Like, take the car example. Like, if you go with the fastest speed or with the lowest speed, in both cases, you're not the most energy efficient. So there is this sweet spot for everything, though. So there is also a sweet spot for performance, for speed in your code that you can fine-tune, like see, okay, how I can actually like make this trade-off and make it more efficient, and also in terms of like performance and also energy. For data structures, looking at the big O and the complexity of the data structures and the operations would help a lot in finding the right way. And also, you need to be careful about the operations you do on different data structures. For example, this research is comparing different collections in Java, and it's just like different operations. 3 different kinds of operations, like for example, insertion one item in the beginning, or in the middle of the collection, or at the end, right? And you see that some of the collections that do good in one type are doing really bad in another type. So the message is that you need to be careful, like what kind of operations you want to do, and then based on that, choose the right data structure. Okay, so takeaway messages is that we have 3 tips that is going to improve a lot in your data science ecosystem. And some of them can actually be applied in any software engineering case, right? First is that monitor your resources. Because at the end, okay, we have the software can be efficient or inefficient, but at the end, the hardware is actually consuming the joules. So it's really important to be aware, like what kind of resources you're using, and be aware of like underutilized resources and try to minimize that. Second option is to choose your models wisely and be mindful about the decisions you make, and don't use the algorithms just fresh off the shelf. Try to understand like what kind of parameters you can tune better to make it more efficient. And lastly, optimize your code for the purpose of resource efficiency. Okay, that was my talk, and we are hiring. If you have any questions, I'm here to answer.